now the world is starting to look at extracting hydrogen from underground. Nobody looked at hydrogen stored like natural gas, but there are reserves of hydrogen sitting in pockets underground. And
what's the chances those pockets are close to where we build data centers today?
This whole thing is also very new.
Sure.
There are a number of enterprises that are starting to look for it, and I don't know where they are, and but there are large reserves of hydrogen underground. So now we're talking about quote unquote green hydrogen without at much lower cost, and eventually, the world is going to build a network that will parallel the methane, the natural gas network, and that will address some of these problems.
So to that end, I look at this and I go, is our reluctance to pick the next lifeboat for power that we're gonna eventually run into a situation where we don't have the ability, to provide the power requirements that are being asked of us today? You said from 1980 to 16, so in 36 years, you said that you saw 8 major incidents where 1 million people or more were impacted, and
in this country.
Yeah, and since then, hundreds of them, it sounds like, and I don't think it would be unusual for anybody that's listening to this podcast to be like, yeah, we get rolling blackouts in the summer or the winter or whatever. Is there anything that maybe people don't want to invest into, hydrogen or methane, or because they're waiting for what the next economy of power is going to be built upon, right? Because what we're talking about is how to solve for current power demands based on all the criterion that you described. There's people coming back to manufacture, there's, adoption of AI, and there's a lot of other things that are being used that we just don't have the control over controlling the adoption.
I think that, for me, I think that SMR are very exciting. And I think that the world is starting to change opinion, perception about nuclear. Obviously, it's either the nuclear danger or global warming, and which one is worse? But then you look at these SMRs and the design, the construction. You look at light water type reactor, which has been used by you've been on one
right.
on submarines for 60 years, and I don't recall any nuclear incidents,
exactly,
and or carriers, and fast neutron reactors, which are very safe. And
I think there was a lot of propaganda that came out in the 70s and the 80s.
Yeah, because
nuclear weapons.
And 3 Miles Island and Chernobyl, but these are different design, and for fast neutron type reactor, the fuel is good for 20 years. You don't have to replace the
Do you think that's
20 years? But so I think that's very exciting. I think that also you see more and more attempts by data centers to physically locate in the vicinity of existing power plants, nuclear power plants, which has significant benefits, especially in cases where the cost of electricity goes negative because it's so expensive and difficult to shut down a nuclear reactor. For me personally, because of my background, I guess fusion is more exciting. Most people have dismissed fusion altogether for many years because the first tokamak was built in the the 70s, I think, and we still don't have a working fusion plant. But the last 3 years have been all of a sudden there is so much interesting work there. There is this company in Massachusetts called CFS, Commonwealth Fusion Systems, that is using a different kind of tokamak, and fusion. And I don't want to bore you to death with
No,
these
we need to
details.
talk about fusion and the difference between that and fission.
In order to accomplish fusion, fusion is opposed to fission. Here, you have two isotopes of hydrogen, deuterium that has one neutron, and tritium that has one proton and two neutrons. And if you create a magnetic field strong enough that will compress and increase the density of the plasma, operating at a very high temperature, high meaning like 10 times the temperature of the sun, like 100 degrees, 100 million degrees, and long enough, minimum 5 seconds or so, you can create enormous amount of energy by fusion. By fusion, two isotope of hydrogen creating helium. In this process, enormous amount of energy is released, and then there are two ways to do that. Either through magnetic confinement. This is a so-called tokamak, that donut-shaped machine. In the case of CFS, they use this tape, which is superconductive. Superconductivity occurs in the vicinity of 0 Kelvin, a very low temperature. But there is a new type of material called hot superconductive it's not really, cold, not hot. Cold superconductivity. It's not really cold. It's still about minus 200 degrees, so it's pretty hot. So this kind of material, you can wrap it around the tokamak, and you can inject enormous amount of currents, which create extremely large magnetic fields. Just to give you a sense, a tokamak like this could generate somewhere in the vicinity of 20 Tesla. 20 Tesla is, I never thought that something like this could be. This is 400 or 500 times stronger than the magnetic field of the Earth. So when you have that 20 Tesla, you can really compress that plasma with this hot superconductive material. When you have that kind of pressure, that kind of confinement, the likelihood of generating positive energy is very high. And then you have ITER in Europe, the consortium of 28 countries that are building the largest tokamak. This is probably the largest scientific project, multi-nation scientific project ever done.
So they're trying to build basically like a larger toroid for cold fusion.
It's not cold fusion.
It's
fusion.
Not cold. Okay,
it's fusion.
Okay, but I thought you said it was on the cold side.
Oh no! I was talking on the superconductivity.
Oh,
this is the material. This is called hot superconductivity that still operates at minus 200 degrees. It's not that hot, but enables a lot more current to flow through that. The superconductive material doesn't have any internal resistance, so that's the intensity of magnetic field is a function of the intensity of current.
How far out do you think this technology is from being commercialized and used?
Well, none of these will be probably commercially available until end of the decade.
So I ask because one of the things that we're also learning, right, is that AI is doing a lot to help us do a lot of math faster. So, just like the adoption rate for certain technologies, what I have learned is, like cars and electricity, it took 30 to 40 years before we started adopting those mainstream, meaning more than 25% of our population were using those things. And we have learned, as all the unintended consequences of each industrial revolution, the longer that we've had something that's good or bad for us, the longer it takes for us to break our habits of those things. But I also learned, like, we are learning how to adopt emerging technology faster, which is also making it easier for us to outgrow it faster.
Right.
So is it possible that the AI itself or the quantum computing itself is able to help us arrive at the technologies in the future that we need to get to be able to pull in and move the schedule from the right to the left in terms of how fast we can, one, understand the science, two, there has to be messaging that goes out because there's 20 years of conditioning to people who are all nuclear is bad.
Well, I'm sure it is, but let's face it, the issue is SMR. I don't think it's the design. There are 80 companies developing SMRs today in the world. 80. The technology is pretty mature. The issue is regulatory approval. You take Last Energy, for instance, one of the most advanced SMR manufacturers, and they have made the decision to totally bypass United States and focus on Europe. It's an American company, but they're going to install a number of SMRs
because they're more willing to adopt it and let
in
it
the
go over
UK
there.
and in Poland and I think in Romania. But they would go where the regulatory process is
less burdensome.
Yeah, you cannot blame NRC from being conservative because but still it's the process is very long, difficult. It's difficult and it's very expensive, and that's one of the reasons nuclear power plants cost so much money. And then you have NuScale, right? NuScale was the first one to get an approval, and they had a project at one of the national labs in Idaho, and that project got into some trouble. That doesn't mean that the company will not continue to promote their products and manufacture reactors. But the cost of electricity generated by this SMR is not going to be 5 cents. It's not going to be 3 cents. It's going to be more like 15 cents or so, which is
Really?
Yeah, probably when all things are done. I mean, NuScale came back, and the original, if I'm not mistaken, the original estimate of cost of electricity would be like 5.5 cents, and then it jumped to 9. So
where was that at? Do you know which market they were looking to do that at? Just curious.
At
in Idaho?
National Lab.
Interesting, because it's still at some point the carbon footprint and the impact on global warming and a bunch of other factors still means that juice is probably still worth the squeeze, since there are parts.
No, absolutely. Absolutely. The conundrum between lack of power and the need to have a carbon-free power, it's difficult, but we need both. What is the compromise? That depends on every company has. Right now, probably I hate to say that, but probably the carbon component is secondary to availability of power.
Just because we need the power.
Yeah.
I feel that the constraint of power that everybody's facing today will eventually make the small pockets of industries or the small pockets of regions where power is constrained all come together, and then that's where the voice gets loud enough to be noticed by hopefully an industry change agent, someone disruptive enough that has $1 billion and wants to come in and be like, I'll be someone that changes something, right? We're going to figure out a new way.
Right.
But do you feel like at some point, I honestly feel that if we change, I think that this industry is in a unique position because it's the newest industry ever built. It seems like every other industry requires this industry for success, right? The more that they adopt technology, the greater the reliance on data centers. And the more that we rely on data centers as a business, as well as what we do today as consumers, just puts more pent up demand on more utilities. And those utilities, again, if you take electricity and water and network connectivity, which are the primary 3 utilities you use at home, along with the gases, and you wrap all those up, that becomes the 5th utility, and that's a data center. I think that data centers will become a word on everybody's lexicon. People will one day, everyone will know that everything that they have, they'll realize the cloud is a building on the ground that's built to island itself off the grid, and that's what the cloud really looks like. But it's a data center. And I think that when that happens, we're going to begin to realize that we're running in a freight train right now on some train tracks, and the track isn't done being built yet. And we're moving pretty fast towards what could be the end of that, which is the reduction of power. And there's no one that's really coming along right now. There's a lot of people talking about what we need. We need power.
Yeah, right.
We need, less carbon emissions, and we need this, we need that. But no, and we have lots of emerging technologies like hydrogen has been around forever. And even now we still can't get it to pencil out more than 40% efficiency of cost or 30% more efficiency of cost, depending on green or gray or brown, right? So if you continue to look at those trends, we're not iterating and evolving fast enough on that to make a difference. I could be totally wrong. What the heck do I know, right? But what I'm telling you is, I do know that a long-term, sustainable, scalable solution has to be nuclear, and I feel like everybody should.
You're right. Yeah, no argument. But the world is not passive. It's, you look at Europe, for instance. There is this North Sea program, which is mind-boggling. These are offshore windmills, wind turbines, and they are talking. I mean, it's going to be a long time, and I don't know if economics will work, but they're talking about 250 gigawatts of power generated. The winds in the North Sea are fairly constant, and the projections are that they're going to run at least 80%, and they're talking about building also making hydrogen right there. Using the power and then shipping the hydrogen, pipe the hydrogen to the
because that's the only efficient form of storage. It sounds like right now, right? Is hydrogen converted to
ammonia? Yeah, it is, and large amounts. But storing hydrogen is not easy task either, because you either store in tanks at high pressure or in cryogenic tanks at liquefied as a liquid. But that takes space, and it's relatively expensive.
So we have hydrogen, we have renewables, and we have nuclear. What else do we miss?
Well, we have geothermal is an interesting proposition.
I don't know what that is. What is that?
It's hot water from the depth of the earth. 40% of electricity in Iceland is geothermal. It's just but there are large reserves of geothermal power in Texas and in Nevada. I know of a company that's looking at building data centers in Central Valley in California using available geothermal power there. Google had built a small project in Nevada, if I'm not mistaken, using geothermal power. But there are large reserve of geothermal in many parts of the world. And the reality is that this extraordinary growth of data center is global. It's not United States alone or Western Europe. It's everywhere. Africa is a great destination. It's a really big destination now. There is a lot of money and a lot of infrastructure being built in various parts of Africa and Southeast Asia, obviously China, Japan. You see a lot of projects in the Philippines, in Indonesia, in Vietnam, Thailand.
Why there? Why are all those other markets emerging more than?
Well, because that's you have data centers where, in general, you have data center where there is a large population that needs the product that is stored in data centers. So Indonesia and Philippines are very large countries, very large populations. Then the CEO of NVIDIA is talking about sovereign data centers, sovereign AI. That what it means is that the development, what the parameters used in building the learning, the training data centers are unique to every country. Whatever data and information, all of the stuff used to train machines in this country might not be applicable in Bahrain or in Cambodia, or whatever. So each country and a number of countries, some of them in Europe, some of them in Asia, are already starting to build their own sovereign AI. So this is going to be a global build-up. It's not going to be just this country or just Europe.
Well, listen, welcome back, and thank you for letting me have my tiny tank break. I was thinking about it on the walk. Like, don't be concerned about how much content you're putting out. And I know that you're uncomfortable because you've got a big fat brain and you don't want to bore people, but I don't think that this podcast is only designed for those that are listening today, right? I think that there's going to be something's going to happen in this industry. It could have been like on the drive here, you and I were talking, we're like, what happened to AT&T last week? Everybody that's got AT&T was impacted last week. I know I was. You're in this industry. I'm in this industry. The first thing I thought of is, I wonder if they had a power outage, right? But, talking to someone on the way here, it sounds like it's probably more of like a network or a hardware error or something like that. But the truth is something's going to happen, and this industry is going to bust loose, and it's going to become mainstream. Right. And when it's mainstream, people are going to start scratching the paint. I think that you're going to start really seeing kids doing more research on this industry in college, and they're going to be writing papers about this industry in college. And then as they go back and they investigate this industry, they're going to track it back down to the biggest companies and the people that started this industry. And I think that your name will be found. I think that someone's going to listen to this podcast in 2 years from now, and they're going to write a paper on it in college. And they're going to talk about the trends that you talked about right now between, multiple different iterations and versions of hydrogen as a solution and partnership. And it solves storage problems. But at the end of the day, fusion is where we're heading. And we need to figure out what that roadmap looks like between here and there. I do want this to be so latent with data because the people that don't want to listen to it, Peter, they ain't for us anyway. Those people aren't going to make a difference in this industry. They're just here to collect a paycheck and try to figure out. They haven't seen the ball since kickoff. But believe it or not, this is a pretty sophisticated industry, and a lot of people are really smart, armed to the teeth. And a lot of those people, they genuinely want to know more, right? They genuinely want to. And look, unless they're going to go to a conference and get to listen to you talk for 20 or 30 minutes, this is a 2 to 3 hour podcast that people are going to be able to listen to on their drive to the airport or their drive to their office or their workout at their, at the gym when they're on their when they're out running the trails. And I want it to be deep because this is intentionally designed for people to go backwards and re-listen to it again. I know I will. I lag by a couple of podcasts and all the ones that we record, but I just got done with Christian's first part, right? And I'm like, man, I have so many stuff that I took away from that one. Same with Snowhorns. I had to listen to his again too. So I think that this podcast is one that I think when this industry becomes mainstream and people start discovering the pioneers of this industry and they start doing research on all those things, this content will be here. And you're going to be talking about, first, you said it into the microphone where you admitted that you didn't have a crystal ball and you didn't predict all the things that were going to be happening 25 years ago when we started this industry.
Not even close.
But nobody could have, right? Even now, I wouldn't feel comfortable. I would feel comfortable predicting anything beyond 6 months from now, as long as it was binary, meaning it fell into a category of either it's going to be really, really heavily focused and latent on growth, or it's going to be stagnant or idle. It's definitely not going to be idle or stagnant, right? We are growing faster than every other industry because of every other industry. And the number one, that there is an existential threat to this industry. And depending on who you ask, they're always going to have the same two answers. It's just which order does it come into. It's either power or people and power. And I always say it's people first, because the people that we need to enter this industry that are going to make the differences, they just don't know about this industry yet, you know?
Right.
And once they discover this industry, the people that we bring into this industry are going to be the biggest change agents to it, because it's been fairly incestuous. This industry is very small, it's very niche, and it doesn't take long before you know a lot, you either know of or know the certain other players in the space. Do you agree?
Totally, yeah.
But we need big fat brains, young, hot, passionate people that want to stop climate change and find, you know, a more tenable solution to energy that probably takes a lot of pressure off the conflict between nations, specifically when it comes to war over energy, right? So there's a lot is going on this, and what I want is I want to start collecting these narratives. So please share as much as you can in the time that you can before I have to get you back to the airport. But look, we talked about what is necessary and what is available, right? What is necessary is power. What is available are these various, you know, electrical permutations that exist. And we haven't even got into the cooling side. I wanted to spend just 10, 15 minutes more scratching the paint on what you were going through with AI. And that's a whole nother podcast. You know, maybe that's a discussion topic for DCAC 2024 this year, either in Dublin or here. But what we want to talk about is, we know that we have gigawatts of erosion of current infrastructure that's happening. And simultaneously, we know we have gigawatts of pent-up demand growing for more power. So we know that what we're currently doing isn't being done fast enough and not at a large enough scale and in a way that's sustainable for the climate. So we know that we need to take a much bigger leap into something that's more tenable and scalable and reliable and safer for the world. And we've talked about what options we have as Band-Aids to get there. But when we got into the solution for fusion, really, I stopped us there because I felt like the technology that we're helping unleash is going to also help us get closer to or faster to a more reliable power solution.
Right.
So that leads us back to AI data centers, right? And with AI data centers, we're talking about incredible densities of capacity that are going to go into those things. And those racks are going to be massively heavy and incredibly more robust than they even are today, right?
Right.
What's that AI data center look like in your opinion? Now I do ask you to have a prediction of, 6 months down the line, more than 6 months down the line. What are you getting ready for and what are you bracing for? What are you telling all these companies that you advise, this whole industry that you advise collectively? What are you telling us that we need to do from a power perspective?
Yeah, not only power, but I think that what I'm telling them is get ready, because this is a totally different animal. It's a different type of data center. It's not a variation of your typical enterprise data center or cloud data center. There are aspects of AI that are unique in terms of power distribution, density, cooling, structural, architectural, and unless we all understand these intricacies, these differences, we're gonna have problems. Especially the first big data centers will probably, people realize that they didn't account for this or that. Right now, most people are focusing on cooling, and rightfully so. These densities are obviously unheard of, and as the GPU is evolving, go from 400 to 750 watts to 1200 watts. We're going to go to 2000 watts. And that translates into densities. We're going to go, from the common 8 to 10 to 20 to 40. 40 is right now the most common number. And from there, we're going to go to 70. From there, we're going to go to 100. And who knows how much, people are talking about 300 kilowatts per cabinet or so. And that creates extraordinary problems. There is a lot of uncertainty about the type of cooling, whether is direct to chip, cold plate, or immersion, and I'm pretty sure that direct to chip will win, especially for AI data centers. Though immersion cooling has some place but maybe other environments. Whether it's single phase or two phase, whether it's going to have redundant CDUs. I mean, there are so many aspects there, and not NVIDIA or nobody has come out and say this is the way we're going to standardize it's if you look at an AI data centers right now, if you look at the big AI players, each one has a different configuration, the different kind of most often a distributed architecture using OCP. But then you ought to think about the fact that when you have to provide 100 kilowatts to a cabinet at 48 volts, what kind of power supply are you going to have to use, and how you distribute? How are you going to distribute what? It's close to 2,000 amps. I mean, this is a big bus bar.
And how are you going to cool it?
Yeah, and this is not your 16 amp rack PDU. And then how are you going to cool it? The thing with Novak and the two-phase Forever Chemical has created another level of uncertainty about the whole cooling process, because right now there is a lot of unanswered questions about the physiological impact of this type of two-phase coolant like Novak, and what are the replacement, and how soon they're going to become available, how efficient and effective they're going to be. We're going to use what kind of coolant. We're going to use water. If we're going to use water, what is the risk of leaks? And electricity and water don't really like each other very much. So how do you prevent these kind of things? There are all a whole slew of questions that are being addressed as we speak here. All the major players in this industry are experimenting with different technologies, different products, and cooling solutions. Right now, we are not there yet. You can do air up to about 40 kilowatts per cabinet. I mean, you have to have very, very tight containment. But it can be done. It's probably a little tight because if you lose cooling there, you can do a lot of damage quickly. There is not a lot of inertia there. The intermediate steps between air and liquid would be a hybrid using a combination of air and water, such as rear door cooling, some form of indoor cooling also, but primarily rear door cooling that can bring us to maybe 70 kilowatts per cabinet or so. Beyond that is going to have to be liquid cooling, 100%. Now, what kind was who are the main suppliers? I mean, there are a lot of players in this field. There is not a great deal of business yet, but the projection is that we're gonna use a lot of liquid cooling in the next few years. So there are a lot of people getting ready for this. So the whole cooling is complicated, a little bit difficult. The technology is there. I mean, we know how to do it. It's just how we implement it, how complicated it will be to modify the server, because regardless of technology, almost without exception, the standard server will have to have modifications for different type of liquid cooling. And whether this is going to be done by the OEM at the factory, the server manufacturer, or going to be done in the field, that still remains to be seen. And then, as I said, we have power. We have the issues. The power profile is violently different than what we are accustomed to. And what will that do is the support infrastructure, with upstream distribution systems, and even with the utility, that also remains to be seen. We don't see it yet because we don't have AI facilities of that magnitude. But when you're going to have hundreds of megawatts operating like this, and we're going to have these large swings of power, typical for AI, and primarily learning, but also you see that in inference data center, you need to address that issue, and then we won't be able to operate at 120 to 208 volts like we did for the past 30 years. Not at 100 kilowatts or so per cabinet. So we're going to have to go to much higher voltage, whether it's 480 volts or now we're talking about maybe 750 volts or even higher. What does that mean? Now we need to be concerned about arc flash in the data center, right? And that's another issue that we need to be concerned about. Operators are not accustomed to work in that kind of higher voltage environments, and so. And then from a structural standpoint, when you have these cabinets that are a ton and a half heavy, the traditional data center is not designed for that kind of.
I just envision like a swimming pool full with some sort of glycol or mineral oil or dielectric or whatever they call that mineral. And it's just a ring bus around it of medium voltage that's tethered into things, that goes into this bath. So that's where the racks will go. They'll just be immersed, and then you'll have medium voltage supply and distribution.
Well, maybe not the pool, but tanks, and that's you see that especially Bitcoin crypto mining facilities are like these. Operators, based on my discussions with them,
I'd rather just go with the tanks.
Rather goes with cold plate with direct to chip cooling, and
gotcha.
You have better control, and you have the ability to to more closely
Reject the heat.
rejecting the heat. You can take the hot water, hot liquid, and recirculate it. You can reuse it. It's much easier to reuse the heat from in liquid form than in gas form. So yeah, there are other types of immersed cooling. Instead of having the whole cabinet and low rack immersed into a tank with oil, but you can have each server essentially encapsulated and running a liquid through that, which is more advantageous because with direct to chip cooling, maybe only 70-75% of the heat is rejected by the coolant. You still have other components, some memory, power supply, a few other things. You have CPUs that are still need to be cool. So you're going to have some conventional cooling using conventional air handlers like a traditional data center, but much smaller in size than a conventional data center. So and then the whole issue of latency, the fact that all these GPUs have to be physically close to each other. With InfiniBand, the distance should be somewhere in the maximum 50 meters or so, and so that's one of the reasons we have these enormously high densities. We cannot spread the servers, the cabinets, the GPUs on a large distribution surface, simply because we have to keep them. All these GPU need to be operating in a synchronous manner. So in order to do that, the latency has to be minimized to nanoseconds, and that can be done only if they are physically close to each other. So that's the implication here is that we might end up with multi-story data center just to keep these GPUs more closer together. Now, what does it mean that we're going to have to distribute water? Obviously, it's better to distribute water below the server than above the server cabinets, right? So that implies that we're going to have raised floors, maybe not 1 or 2 feet raised floor, but maybe 6 inches. But still, what does it mean when you have a raised floor and you have
3,000-pound rack
cabinets of a ton and a half? So all these things need to be, and there are many others. Elements in the design, in the construction, in the operation of these data centers that have to be accounted for, that they have to be well understood, analyzed, and optimized. We are, as I said, we are in the very early stage of this journey. What concerns me a little bit is that all the AI players are keeping their concept and their design close to their vest. There are very, very few standards that are becoming widely circulated. So it's gonna take a bit of time until we're gonna have a concept like OCP that brings all the major players together.
It does seem like everyone's secret sauce right now.
Yeah, right now, and it's fairly typical for a new industry, for a new product that
It's a secretive.
Eventually, this will be more better understood, publicized. We're gonna see more paper about this. So the industry is going to be educated, but at this stage, I'm a little concerned that there is not a very good understanding of how this data center is going to look like. And considering the fact that companies are spending hundreds of millions or billions of dollars building something like this, you better do it right.
Yeah.
We can hardly afford to make mistakes at this stage.
Yeah, we don't have a lot of resources in labor or power or water to really waste doing this the wrong way.
That's right.
Not being good enough to be utilized. I can't imagine, Snowhorn was telling me, hey, we're doing 2,000 megawatt or 2,000 acre campuses on, 1, 2, 3 gigs at a click. I'm like, can you imagine at that scale when you make a mistake, the magnitude of impact is much different than when you're doing it at a micro level, right? So wholesaling to the wholesaling. All right. So and as we bring this one home then, because I want to get you back to the airport, are there any predictions that you have regarding power? Or do you think it's going to take, 5 years for this or 10 years for that or 15 years for this? I mean, what do you see happening to this beloved industry that you helped start?
A question I've been asked many times in the past year or so is question is this a bubble or it's real? Because a lot of us went through the .com bubble, and there is concern that and this is at least an order of magnitude, maybe 2 order of magnitude bigger in size than the .com explosion. So my answer is that I honestly do not believe that this is a bubble. I think that it's real. I mean, these are real companies making a lot of money. The AI in particular will have such an impact on everybody's life. It's the biggest thing since the internet, if you come to think of it, and look what the internet has done to mankind. But the impact of AI at every level, whether it's industry, in politics, in healthcare, every element of human life. And every company, small or big or small, eventually will have to have an AI capability. Right now, even companies that don't know anything about AI and have no idea how to use AI or what to use it for, they are still getting engaged and have plans. And I mean, it's a FOMO thing. It's a fear of missing out, that's why we see this enormous amount of money being
invested into the space,
spent and invested in this domain. Yeah, right.
How do you feel like there will be a time where these data center operators, the owner operators themselves, will eventually have their own reactors?
Yeah.
You think so?
Yeah, I think so. I think that it's going to. A lot of people will, like anything else, will wait and let's have someone else try it out first, and then we're gonna right. But you're gonna see them operating in China. We're gonna see them operating in some parts of Europe, and the
SMRs.
I'm talking about this SMRs.
Okay, so you think that they'll be adopted in other countries before they are here?
Absolutely, yeah.
Okay, and then once it's proven to be a safe solution in those other places, then it'll soften up for us to be able to adopt it here.
Yeah, and the biggest problem we have. Yeah, generation is a big problem, but the transmission and distribution is more difficult. It's so extraordinarily difficult to build a transmission line, and it's so difficult to, it costs. The projection is in order to bring the U.S. grid to the point where it's all the unreliability to the aging issues will address. It would cost north of $2 trillion. So
Is that based on? So I I always hear numbers like that, and I think of two things. I think of I don't know what it used to cost to send people to space or to launch a rocket into space.
Well, less.
But I imagine that once it was turned over to, private corporations to do, they found ways to do it cheaper and faster. So if we're talking about government years, government dollars, I think of it I'm sure I'm sure SpaceX is launching rockets at a cheaper rate in which NASA was, right? Because they're a business that was trying to make sure they weren't doing it for, $400 toilet seats type of thing. They were trying to figure out how to do this as efficiently as possible. And I'm hoping that maybe the more these things are commercialized more and less dependent on the Department of Energy or something, I don't know, some element of government, that we'll start seeing these things pencil better, which makes the adoption rate faster.
Yeah, well, I'll give you an example, and I think it's pretty indicative of the magnitude of this issue. Remember Sandy?
Superstorm Sandy, yeah.
What it did to New York?
Yeah.
The cost associated with that was staggering. So, but still, to fix all those problems associated with this is only Con Ed, only New York City. The cost associated with repairing all the damage done by Sandy will add about 3.5 cents per kilowatt hour in cost of electricity, which is significant, but not.
It's probably 25-30% cost total right now.
Yeah. To retrofit the distribution, the Con Ed distribution system, to make it weatherproof, to avoid another disaster similar to Sandy, to take all the substation, raise them, to put all those overhead distribution underground, to do all that, will translate into the utility bill for your typical consumer to go up not 3 cents, but 300 cents, $3.
Yeah,
100 times more. So guess what's going to happen?
Reaction. Yeah, they're not.
That will never happen. They cannot increase the the utility rates by such an incredible number. So that's one of the reason doing a distributed generation in various formats, avoiding long transmission lines and even distribution line will be a way to overcome some of these issues.
I just kind of feel like what you have is you have private or commercialized businesses that are trying to get it going, but they're waiting on a government that is taking forever. And the government, essentially you're handing a complicated problem like this over to the DMV, right? So we know how well the DMV does with just getting you a driver's test and an automobile license, right? I can't imagine turning something like this over to the DMV, in another government department, to try to figure out how to advance for us, right? So I look at things and I still don't see. I think that what this industry needs is a disruptive change agent that can use the data centers as the final tipping point and the final straw that broke the camel's back to addressing an energy problem that we've been kicking the can down the road for since the last 40 years, right? So we need to probably start solving for this now. And if we started, who knows where we would have been 20 years ago if we started bifurcating nuclear weapons from nuclear energy. But we're doing that now, right? And I'm hoping that these podcasts will draw in, I've probably had 5 to 10 people that I don't know that had heard just snow horns on power. And they solicited or nominated someone else to come on the podcast and talk about power, people from energy groups I've never even heard of before, right? And maybe that's what this is for, is to, as you're making this part of your primary responsibilities as an industry thought leader, is to help us figure out how we're going to capture this solution on energy. I think it's going to take a lot of people. It's going to take you talking about your stuff with all the people that are in orbit with you. But I think that the crisis, we need to talk about it in the terms of a crisis, because I think
it is a crisis. Yeah, there's no question about it. But in the same time, I'm optimistic that we solved many other problems.
You better get to work. Your grandkids may be in this industry. What are they going to think when their grandfather didn't solve this problem before he retired?
Well, they don't think much of their grandfather.
Oh, I doubt that shit. My thing is this is the problem. This is everything that we do begins and ends with, finance in this industry. And right now, this industry is measured on what it sells from a product basis based on power. So we have to solve for this. And I think this is hopefully the final push. This is the industry that breaks the camel's back as it becomes mainstream. And now it allows itself with its voice to bring more attention to this crisis of power. And then hopefully you and the rest of the data center fight clubs could all come together and help put that voice together using platforms like our conference or, this or other platforms like Interglobix and all the other conferences that exist, but start really getting everybody to focus hard so that way we're all reaching out to our networks and figuring out who's going to come in here and stake something like, and arbitrarily here in 7 years from now, this data center company is going to have nuclear power.
I'll tell you, I cannot say enough about what the kind of what you do for this industry, but to bring all these people and really discussing the issues facing our business, our industry, bringing some clarity and some helping people going through the decision process. But the kind of benefits you are bringing this industry is extraordinary. So, I say thank you. I mean, this is I really appreciate what you're doing for this business.
Well, listen, Peter, you've been a huge influence on my entire career. I was fortunate enough to discover who you were early on in it, right? And I've been in this industry since I got out of the military in 2000. But it's been a pleasure, to host you for the second time on this podcast. For those that didn't get to hear your first one, if they want to hear a true American hero story, they need to listen to that podcast. I got emotional actually when I listened to it after we recorded it. But it's just a privilege to sit around with luminaries like you and Christian and others that I'm going to be able to have on this podcast to talk not only about what you did to get into this industry and how you helped push it to where it's at, but what you're doing now to help it continue to sustain and grow. Because right now, people like me don't have the authority or the influence to make a big change, a meaningful impact on what we're going to do for energy.
Well, no. What you're doing is very powerful and meaningful impact. What you're doing is really, really moving this industry ahead.
Well, listen, I appreciate it.
Else. No, seriously, discussing these people with a much larger audience and educating the industry is, I think, it's extraordinary. There are no other forums. There are very, very few utilities that will enable people to gain that kind of knowledge and the information as what you are providing, what you are bringing to the industry.
I tell people that what I do for a living is I build the engine for AI, right? I'm like, we're trying to build the largest utility ever created by using every other utility to do it. And that newest utility that we will be creating, that's known as a data center today, will have the greatest impact on humanity, more so than any other vertical of industry combined, right? So I do think it's an honor to have guys like you on this podcast. There's a few other powerhouses that we have coming up, thanks to some of your help as well. And we're going to continue to just focus on this until somebody outside the industry who doesn't understand what the cloud is, doesn't understand where the home for AI sits, is going to realize that it's a really, really, really small industry. So when people talk about AI and they think about cloud, there's a good chance that every day someone touches their phone 5 times in a way that touches a data center that you've had an involvement with. That's how small the industry is. That's just not how powerful you are, right? So I appreciate everything you've done for this industry and for me professionally and personally, and it's an honor to know you. And thank you for sharing your thoughts on energy with us. We will come back again before DCAC, in September, And let's talk more about that AI data center and what that profile looks like. Let's just scratch the paint more on the mechanical and electrical and figure out what are you going to do to solve for those levels of density and that much power and aggregate volume of cooling that's necessary to support it. I mean, that's going to be bananas.
I'm looking forward to it.
All right, Peter.
Great.
Well, thank you, sir. Safe travels home.
Thank you.
Thank you.